Bilberry is quietly dismantling the cataracts, the floaters, the night blindness that your optometrist charges $400 to tell you is just aging. That ends today. Bilberry contains a compound called Anthocyanins. Think of it as the deep violet ink your eyes were always meant to run on. And a landmark study published in the Journal of Agricultural and Food Chemistry confirmed it doesn't just slow retinal degradation, it actively rebuilds the photoreceptor cells responsible for low-light vision. Your rods and cones are literally drinking this pigment like a dry sponge under a faucet. To use it, grab a half cup of fresh or frozen bilberries every morning. Blend them into water, no sugar, no dairy, just the raw fruit and its bioactive payload. Drop a comment below right now if you're starting this today. Now here's what Big Pharma doesn't want trending on your feed. Your eyes are not failing because of genetics. They are failing because the industrial food chain has systematically stripped the one class of pigments your retina was biologically designed to absorb. Lutein and Zeaxanthin, the golden carotenoids found in specific plants, are the only nutrients in the human body that physically accumulate inside the macula, the high-definition center of your visual field. When those levels drop, you don't just get blurry vision, you get macular degeneration, you get photosensitivity, you get the slow dimming of the world around you, and a prescription pad handed to you like it was inevitable. It wasn't inevitable. It was engineered. 5 plants exist right now that function as precision biological instruments for ocular repair, not supplements pressed into a capsule by a corporation that needs your refill business, but whole plants, each carrying a distinct molecular mechanism, each targeting a specific layer of your visual system. This is not folk remedy, this is documented photobiology. And by the end of this video, you will have a complete botanical protocol for protecting and rebuilding your eyes, sourced from the ground up. Plant 1 is already in your system from the bilberry intro, so let's go deeper. Bilberry, Vaccinium myrtillus, a wild shrubby cousin of the blueberry that grows in the high moorlands of northern Europe and has been harvested since the medieval period for everything from dyeing wool to treating scurvy. But what the healers of the Scottish Highlands observed centuries before clinical trials existed was that the men and women who ate bilberries regularly seemed to maintain sharper vision well into old. That observation sat in folk medicine for generations until World War II, when British Royal Air Force pilots reportedly consumed bilberry jam before night missions to sharpen their low-light targeting accuracy. The military noticed. Scientists followed. Here's the mechanic. Anthocyanins, specifically the delphinidin and cyanidin glycosides in bilberry, cross the blood-retinal barrier, a selective checkpoint most compounds cannot pass, and directly stimulate rhodopsin regeneration. Rhodopsin is the photosensitive protein your rods use to detect light at low intensity. Every time your eyes adjust from a bright room into darkness, rhodopsin is being synthesized in real time. When anthocyanin supply is low, that regeneration slows. The result is that 3-second stumble in a dark hallway, the struggle to read a menu in a dim restaurant, the creeping loss of confidence behind the wheel at night. Bilberry accelerates rhodopsin synthesis back toward its factory setting. The Journal of Nutrition published findings confirming that regular bilberry consumption measurably reduced intraocular oxidative stress markers, which is the cellular distortion pattern that precedes glaucoma and cataract formation. You are not treating a symptom. You are interrupting the upstream cause. Tactical deployment is simple. Half a cup of fresh bilberries daily, or 2 tablespoons of concentrated bilberry extract in cold water. No heat. Anthocyanins are heat sensitive. Cooking them destroys their bioavailability. The strategic window for fresh bilberries in the northern hemisphere runs late July through September, when the fruit reaches peak pigment density. Outside that window, frozen is your next best option. Frozen within 24 hours of harvest locks the anthocyanin profile almost intact. The synthetic alternative, lutein supplements from pharmaceutical manufacturer, typically isolate a single carotenoid from a chemically processed marigold extract. Stripped of the synergistic cofactors that make whole plant bilberry measurably more bioavailable in peer-reviewed comparisons, the plant wins. It was designed to. Plant 2 is growing in almost every backyard in America, and most people either mow it down or spray it with something that belongs in a hazmat facility. Marigold, Calendula officinalis, not the decorative hybrid your neighbor plants along the driveway, but the original medicinal strain. the one with dense orange and yellow flower heads that ancient Egyptian physicians crushed into eye compresses and Roman herbalists used to treat inflammation of the cornea. The same flower that got quietly industrialized, processed into low-grade lutein capsules, and sold back to you at a 400% markup, still grows wild and free in your soil right now. You have been paying for the extract of something you could be growing yourself. Here is the mechanic. Marigold petals are the single most concentrated dietary source of two carotenoids your macula cannot function without: lutein and zeaxanthin. These are not general antioxidants. They are structurally specific. The macula, the small central zone of your retina responsible for reading, recognizing faces, and detecting fine detail, has zero ability to synthesize these pigments internally. It must absorb them entirely from diet. Lutein and zeaxanthin deposit directly into the macular pigment layer, where they function as a biological sunscreen, absorbing high-energy blue light before it can generate the oxidative distortion that degrades photoreceptor cells over time. A study published in the journal Investigative Ophthalmology and Visual Science found that higher macular pigment optical density, which is the measurable concentration of these carotenoids in your retina, was directly correlated with reduced risk of age-related macular degeneration, the leading cause of irreversible vision loss in adults over 50. The plant fact that most people never hear is this: the marigold does not produce lutein and zeaxanthin for your benefit. It produces them for its own photosynthetic protection. These pigments exist in the flower to absorb excess light energy that would otherwise damage the plant's own cellular machinery. You are, in the most literal biological sense, borrowing the plant's eye protection. Evolution built the tool. You just have to use it. Tactical deployment. Steep 2 tablespoons of dried marigold petals in 8 ounces of hot water for 10 minutes. Then let it cool completely before drinking. Heat extraction is fine here because you are pulling carotenoids bound to plant fiber, not the fragile anthocyanins from bilberry. You can also add fresh marigold petals directly to salads. The fat from olive oil or avocado in the same meal dramatically increases carotenoid absorption because lutein and zeaxanthin are fat-soluble. 5 compounds. Eat them dry with no fat source and your body absorbs a fraction of the available payload. The strategic window is late spring through first frost, with peak pigment density in blooms harvested at full open before midday. Plant 3, and this one will surprise you: fennel, Feniculum vulgare. The tall, feathery herb that smells like licorice and grows aggressively along roadsides across the American Southwest and Mediterranean coastline. Ancient Roman soldiers chewed fennel stalks on long marches, and Pliny the Elder wrote in his Natural History that serpents rubbing against fennel after shedding their skin would use it to restore their eyesight, a mythological observation that turns out to have a surprisingly accurate biochemical basis. Fennel contains a flavonoid compound called quercetin, along with significant concentrations of vitamin C and rutin, a bioflavonoid that specifically targets capillary integrity. Here is why that matters for your eyes. The retina is one of the most metabolically active tissues in the human body, demanding more oxygen per unit volume than almost any other organ. That oxygen delivery depends entirely on a dense network of micro-capillaries, the finest blood vessels in your circulatory system. When those vessels weaken, when their walls thin and leak, you get retinal hemorrhaging floaters. The early pressure signatures of diabetic retinopathy, Rutin, documented in the European Journal of Pharmacology, directly reinforces capillary wall integrity by inhibiting the enzyme that degrades the structural proteins holding those vessels together. You are not treating a disease. You are maintaining the plumbing your retinal cells depend on to stay alive. The plant fact. Fennel is allelopathic, meaning it releases chemical compounds into the surrounding soil that suppress the growth of competing plants. It does not share its territory. It is, botanically speaking, one of the most self-sufficient organisms in the temperate plant kingdom, and it has been surviving without human assistance on disturbed roadsides for millennia. That aggressive survival chemistry is part of what makes its phytochemical profile so dense. Tactical deployment. Use the fronds, the feathery green tops, not just the bulb. Chop them raw into salads or steep them as a light tea. 2 tablespoons of fresh fronds daily delivers a meaningful quercetin and rutin dose. The strategic window for peak. Quercetin concentration is late spring before the plant flowers. Once fennel bolts, to seed the flavonoid profile shifts toward reproductive chemistry and away from the structural compounds you want. Plant 4 is not subtle, and it has been staring at you from the produce aisle your entire life. Kale, Brassica oleracea, the dark leafy green that got co-opted by the wellness industry, slapped on tote bags, turned into overpriced chips, and somehow stripped of its actual clinical significance in the process. Before it was a brand, it was a survival crop. Peasant farmers across northern Europe grew kale through winter because it is one of the only leafy vegetables that becomes more nutritionally dense. After a frost, the cold triggers the plant to convert starches into sugars and concentrate its pigment compounds as a cellular antifreeze response. That frost-hardened kale, harvested in late autumn and early winter, carries the highest recorded concentrations of lutein and zeaxanthin of any commonly available food source on the planet. Here is the mechanic. A single cup of raw kale delivers approximately 22 milligrams of lutein and zeaxanthin combined, which is more than 10 times the average American's daily intake of these compounds. And research published in the American Journal of Clinical Nutrition demonstrated that regular consumption of dark leafy greens rich in these carotenoids reduces the incidence of advanced macular degeneration by over 40% in long-term cohort studies. 40%, not a rounding error, not a marginal statistical signal, a near halving of risk. From a plant you can grow in a pot on a balcony in any climate zone in the continental United States. The secondary compound in kale that most eye health protocols miss entirely is indole 3-carbinol, a phytochemical produced when kale cell walls are broken by chewing or chopping. Indole 3-carbinol does not target the retina directly. It targets the liver, specifically its detoxification pathways, and accelerates the clearance of oxidized lipids from systemic circulation. Why does that matter for your eyes? Because the retina's photoreceptor outer segments are composed almost entirely of polyunsaturated fatty acids, the most oxidation-prone structural material in the human body. When oxidized lipids accumulate in retinal tissue, they form drusen, the yellowish cellular debris deposits that are the earliest clinically observable marker of macular degeneration. Kale upstream clears the oxidative load before it reaches your retina. You are not treating the eye, you are cleaning the supply chain. Tactical deployment, raw or lightly massaged with cold-pressed olive oil, never boiled. Boiling kale leaches its water-soluble compounds into the cooking water and degrades the fat-soluble carotenoids simultaneously. Massage a tablespoon of olive oil into 2 cups of raw kale for 60 seconds. This breaks down the fibrous cell walls and dramatically increases carotenoid bioavailability while preserving the full phytochemical profile. The strategic window is late October through February, post-frost harvested kale from your own garden or a local farm. Grocery store kale harvested in summer and cold chain, shipped across 2,000 miles, is a nutritionally compromised version of what this plant is. 5 capable of. Now, plant 5. This is the one that gets locked until the end because most people will not believe it qualifies. And the ones who do understand it will immediately recognize why it closes this list. Saffron, Crocus sativus, the most expensive spice on earth by weight, more valuable per gram than gold at certain harvest grades. And yet it grows from a small purple crocus that produces only 3 red stigmas per flower, hand-harvested over a 2-week window each autumn in the high-altitude fields of Iran, Kashmir, and Spain. The labor intensity of harvesting saffron is why it costs what it costs. But the reason it closes this protocol is because no other plant compound in documented botanical science has demonstrated the specific combination of neuroprotective and photoreceptor preserving effects that saffron's primary active molecule, crocin, has shown in clinical trials targeting human retinal degeneration. Here is the mechanic. Crocin is a water-soluble carotenoid. It's structurally unique because, unlike lutein and zeaxanthin, it does not deposit into the macular pigment layer. It operates at the cellular signaling level, activating neuroprotective gene expression pathways inside photoreceptor cells themselves. A randomized controlled trial, published in Investigative Ophthalmology and Visual Science, found that patients with early-stage age-related macular degeneration who consumed 20 milligrams of saffron daily for 3 months showed measurable improvement in retinal function scores, a result that has almost no parallel in conventional pharmaceutical ophthalmology, outside of injectable anti-VEGF treatments that cost thousands of dollars per dose. The plant fact: Crocus sativus is a sterile triploid hybrid, meaning it cannot reproduce by seed. Every saffron crocus alive today was propagated by hand from bulb division, making it one of the few plants on Earth that has been in continuous human cultivation for over 3,000 years, without a single generation of wild reproduction. Its survival is entirely dependent on human partnership. You are not just using this plant, you are sustaining an ancient agricultural lineage. Tactical deployment: steep 8 to 10 saffron threads in 2 tablespoons of warm, not boiling, water for 15 minutes until the water turns a deep amber gold. Drink this infusion in the morning on an empty stomach. The strategic window is autumn harvest saffron, sold as grade 1 or super negin classification. Identifiable by deep red threads with no yellow or white coloration. Off-grade saffron has significantly reduced Crocin density and will not deliver the clinical payload. While these botanical assets are verified by peer-reviewed findings published in Investigative Ophthalmology and Visual Science, the American Journal of Clinical Nutrition, the Journal of Nutrition, the European Journal of Pharmacology, and the Journal of Agricultural and Food Chemistry, they are tools for self-reliance, not a total replacement for emergency medical intervention. You now hold a complete 5-plant ocular protocol that took the industrial medical complex a century to obscure and took your ancestors a lifetime to perfect. Bilberry rebuilds your night vision at the photoreceptor level. Marigold armors your macula against blue light decay. Fennel reinforces the capillary infrastructure your retina depends on to stay alive. Kale upstream clears the oxidative debris before it becomes permanent damage. And saffron, the final boss, activates the neuroprotective code inside your photoreceptor cells that no synthetic compound has been able to replicate at any price point your insurance will cover. The garden was always the pharmacy. You just needed the map.